remember 10 years ago, the headlines out there, multivitamins are useless, they're harmful, you don't need them, it's expensive urine. That's wrong. It's completely wrong. We now have, it's totally wrong. It's totally wrong. This is gonna blow your mind. We now have 3 large randomized controlled trials, this is part of the Cosmos studies, showing that the easiest thing you can do for your health, for your parents, for your grandparents, for your friends, is take a multivitamin supplement, and it's affecting the way you age. So we know, and it's never too late. Okay, so these Cosmos studies were done in older adults. They're 65 years and older. They took a multivitamin for 3 years or a placebo control for 3 years. Those older adults that took the multivitamin lowered their brain aging, global brain aging, by 2 years. 2 years. And they lowered their episodic brain aging by almost 5 years. I mean, insane. Episodic memory is the kind of memory where you're remembering like people, events, you know, the things that like your parents or grandparents seem to never remember. So 5 years, okay? And now we have new data showing that it also lowers biological aging. Easiest thing you can do is a multivitamin, and 3 large studies showing that. So anyone that's telling you multivitamins are useless, arm them with the data. Cosmos studies. All right. Summarize this data because we got to get to the NAD. Vitamin D, 4,000 IUs a day, blood test, you want to be above 30 nanograms per milliliter. Omega-3 fatty acids, we know from studies by Bill Harris, supplementing with around 1.5 to 2 grams a day, in most people brings them from a low omega-3 index of 4% to the 8% range where you want to be. Multivitamin doesn't get easier than that. And then magnesium is something that you can also supplement with in addition to eating your dark leafy greens, because we still need to eat a healthy diet. Okay, we're going to shift gears and talk about NAD. What is NAD and why is it important for aging? So NAD, nicotinamide adenine dinucleotide, it's actually NAD+, but I'm just going to call it an NAD. This molecule is required to make energy. Very, very important. It's not energy itself, but in order for your body to use the food that you eat, to use the oxygen that you breathe in, because both those things are how our bodies make energy, you have to have NAD to do that. Without NAD, you cannot make energy. So it's crucial for everything, right? Because everything requires energy, everything that we're doing, neurotransmitter, repairing DNA, immune function, right? Everything. But in addition to that, it's also a cofactor for many different enzymes. Like I talked about magnesium, it's doing the same thing. And we're going to talk a little bit about that because there's some important enzymes that it is a cofactor. What I mean by cofactor is it kind of like binds to that enzyme and makes it function optimally. And when it doesn't do that, that enzyme isn't functioning correctly, right? So it's not really doing its job. It's a problem. It declines with age, and let's talk about why it declines with age. So our bodies can make NAD from different precursors like vitamin B3 precursors, niacin, nicotinamide, tryptophan also to a lesser extent. But the real reason that our bodies are declining in terms of NAD with age isn't necessarily because we can't make it, it's because our bodies are consuming it so much due to inflammation, increases in inflammation, and due to increases in oxidative stress that are happening with age. And if you add on obesity, metabolic syndrome, type 2 diabetes, if you add on all these other diseases, then we're talking massive, massive problems because there's a lot of inflammation and oxidative stress going on. So it's the cellular demand that's happening as we age that's really causing our bodies to consume NAD. One of the biggest consumers of NAD in our body is from an enzyme called PARP, P-A-R-P. And what this enzyme does is it repairs damage to our DNA. It's very, very important. As I mentioned, if you have damage to your DNA, particularly if it's on both strands, it can cause genome instability. It makes cells age faster, not function correctly. But more importantly, it also increases cancer risk, which is why cancer risk is an age-related disease. It starts to increase in our 50s, 60s, 70s, right? So as we're getting older, we're having a lot more oxidative stress. PARP is literally a sink. It is just massively consuming that NAD. And so what happens is other enzymes that are involved also in the way we age, like sirtuins, for example. Sirtuins need NAD to function. These are also important enzymes that are changing the way we age because they're regulating a lot of different genes. They're histone deacetylases. That means they're basically epigenetically changing hundreds of different genes, many that are involved in the way our mitochondria are working. Our mitochondria are what's making energy. It's involved in lowering inflammation, in allowing our cells to be more resilient. So it's regulating a lot of different genes that helps our body deal with the stress of aging, deal with the stress of, maybe you went out and partied that night, right? So your body can handle it a little bit better. When sirtuins are not being able to be activated, that's not happening. And they're not activated because the PARP is consuming them so much. And the PARP is consuming them so much because we're increasing our inflammation and oxidative stress as we age. So it's a kind of this cascade problem that's happening that all points back to a shortage of NAD. And so some solutions that have now this is like growing field. I mentioned that our bodies can make our bodies can make NAD from vitamin B3 precursors like nicotinamide or niacin. Tryptophan is another one that can be, shunted into that pathway. But there are other precursors as well. Nicotinamide mononucleotide, NMN, is a big one that's being studied. It's also part of the pathway that it's involved in producing NAD. It's actually the step before making NAD. You can't actually supplement with NAD itself because our cells make it. There's no way to transport it into the body. And so supplementing with NAD itself doesn't work. You have to have the precursor like NMN, nicotinamide mononucleotide, in order to get that NAD. And there have now been a variety of studies that have been looking at nicotinamide mononucleotide, so supplementing with it in clinical populations. And like I said, this is a brand new field, very exciting. We have some new clinical data, if you look at the scientific literature, that supplementing with NMN, early studies show LDL reductions, so LDL cholesterol can lead to cardiovascular disease. We show that there's studies showing that diastolic blood pressure is lowered with NMN supplementation. Metabolic health is improved, so even as little as 250 milligrams a day for 10 weeks, improved insulin sensitivity in muscles in postmenopausal women. And also we know that there's a really good bioavailability. So taking NMN in a higher dose, like 1,000 milligrams a day, this is like a real high-end dose, it actually doubles the NAD levels in our blood for about 14 days. In terms of exercise performance, this is another field I'm pretty excited about. There's studies showing that supplementing between 600 to 1,200 milligrams a day can improve oxygen delivery during exercise. Again, coming down to energy production. But it's not just about energy, it's also about not making sure that sirtuins also get that NAD, right? You want to make sure PARP isn't consuming it all. So this is a really exciting new area. NAD is important for the way we age, and the fact that there's now clinical studies showing that NMN supplementation can increase NAD levels and have, outcomes that are beneficial is very exciting, and I'm really excited to continue looking at the field. So, in conclusion, we want to avoid micronutrient deficiencies. We talked about that. NAD plays an important role in aging. We want to not have such high inflammation and oxidative stress, but also it's promising that there might be ways around that in terms of taking some of these NAD precursors to increase our NAD. And with that, thank you so much. Sorry, the last part was accelerated.